Alright, hi everyone. So for the following compound, let's number 1, draw the appropriate Lewis structure, and number 2, identify the type of orbital used by every carbon to make chemical bonds and estimate the bond angles. So let's start with number 1, drawing our Lewis structure. Right, so recall that when we're drawing a Lewis structure, the first thing we have to do is figure out the total number of valence electrons. Right, so let's go ahead and let's do some math to start us off. Because we have 1 carbon and we have 4 bromines. Right, so recall that carbon has a total of 4 valence electrons, and bromine is a halogen, so we have 7 valence electrons, but there's 4 bromine atoms, so we're going to go ahead and multiply that by 4. So that equals 28, and so 28 plus 4 is going to equal 32 valence electrons. So we have 32 electrons to work with here. So now that we've done that math, we can go ahead and we draw the atom with the highest bond preference in the middle of our Lewis structure. And in this case, that atom is going to be carbon. So what we do here, now that we've put carbon in the center, we're going to propose sigma bond framework, right? Which means that we're going to go ahead and connect our carbon to our 4 bromines via sigma bonds. So we have a total of 4 sigma bonds. And on the side here, I like to kind of keep a tally of my valence electrons, right? So if I have 32 to start off with, I've spent 8 because I just made 4 sigma bonds. I just spent 8 electrons by making those 4 sigma bonds, which means that I have a total of 24 left over. And those 24 I'm going to use to complete the rest of my octets. Now, carbon in the center has 4 sigma bonds, which means that it already has a complete octet, but the same is not true for our bromines. Right? So we have to complete our octet for our bromines by adding 6 additional electrons per bromine atom. And what I want to bring to your attention is that if we add 6 electrons to each bromine atom, that's going to give us a total of 24. Right? So we've spent all of our electrons, and in this case, all of our atoms have a complete octet. So we are good. So this is going to be our Lewis structure. It is a carbon atom with 4 bromines single bonded to it. So this was part 1. I should have labeled that from the start, but this was part 1. And now, based on our Lewis structure, we can go ahead and focus on part 2. Right, so for part 2, let's go ahead and figure out the orbital used to make chemical bonds by figuring out the hybridization of our central carbon atom. So recall that when we're talking about hybridization, and part 2 I'm going to focus on the side here, recall that for hybridization we can figure it out for a given atom by counting how many groups are associated to that atom in question. Now, when I say groups, I'm referring to the sum of 2 different categories, right? I'm referring to atoms bonded to the atom in question, but I'm also referring to lone pairs of electrons. So like I mentioned before, when you total up the number of groups you have associated to an atom, you can figure out its hybridization. So let's go ahead and let's figure out our total groups for carbon. But before we do that, let's first clarify a few things. Right? If we have 4 groups associated to an atom in question, we're talking about sp3 hybridization. 3 groups indicates sp2 hybridization, and 2 groups indicates sp hybridization. So now let's talk about our carbon in the center, right? Because carbon has 4 atoms bonded to it and 0 lone pairs. So 4 plus 0 means that we have 4 groups attached to our carbon atom in the center, which, according to the discussion we just had before, is going to indicate sp3 hybridization. Right? So if we have sp3 hybridization, then that is the type of orbital used by the carbon to make chemical bonds. And to answer the last bit of the question, recall that sp3 hybridization means that the bond angle between carbon and bromine is going to be 109.5 degrees. So our Br-C-Br bond is going to be equal approximately 109.5 degrees. And so now we have answered every part of the question. Right? We figured out our Lewis structure first and foremost. And then based on the Lewis structure, we figured out the hybridization and therefore the bond angle. So that's going to correspond to option D within the multiple choice. And so if you stuck around to the end, thank you very much for watching, and I hope you found this helpful.